Hey, hi folks. This is the first lecture of week 6, and I want to remind you that we have a midterm coming up on Friday, June 14th. So what I want to do today is first my last hybrid problem that I want to do, and then I will talk about a few error messages or messages that you may be getting in when you try to do joining operations in solving beam and shell problems. And I'll be glad to answer any questions if there are any left. Okay. So here's the situation. I want to solve this problem. As soon as you see this, you should realize that it has to be done with as a hybrid problem. In other words, this middle piece should be done with solid element. This connection here, these four, should be done with beam elements. And of course, what you see on the outside, this EFGH with the shell elements. Okay. Now, you have to use any planes of symmetry that are applicable. Now, if these were all solids, everything was modeled with solid, then I would take only a 45-degree sector here. Okay, 45-degree sector, because this keeps repeating it based on the information that's given to me. Notice that just looking at geometry is not good enough. You have to look at the edges, these edges A, B, C, D, and you know these four edges are clamped, and these other edges, these edges on the side, are subjected to a force of uh, a total force of 100 pound in negative z direction. By the way, remember that is the total force. Okay, that being the case, you can say that the 45-degree angle, this little piece here, 45-degree angle section, is the smallest finite element model that you can take if you are modeling this in all with solid elements. However, if this is to be a beam element, there is no way you can cut a beam element through its length. Therefore, because this is a hybrid problem, you should take a 90-degree sector as opposed to a 45-degree sector. Okay? So that's pretty much it. So let's go ahead and do it. We'll come to that later on. All right, come to these other issues later on. Remember, I have a choice of doing these hybrid problem as a part or as an assembly. Now I've done 2 or 3 problems, done it as an assembly, and I'm going to do this thing as a single part. So that being the case, I will close that, started with the part file. Okay. And I'm not going to bother with systematically saving these things, and I'll let you do that. By this time, you should know all of these. So on that, first thing I'm going to do is that box in the middle. So that is 2 inches by. I'm sorry. This is. Let's see now. Yeah, this is 2 by 2. You can see that 2 by 2. So let me do that first. On that horizontal plane, I will sketch a 2 by 2 rectangle or a square. So I'm going to model 1/4 of that to begin with. Okay. So this is 2 inches. My units are not in imperial units. I'm going to change them in a minute. And this is also going to be 2 inches. 2 inches. Say okay. Let me go my change your units. So tools, options. Under parameters and measures, units for length, I'm going to use inches. And for force, because I'm given a total force there, so for force, I'm going to use, pound, it's pound force. That's good. All right. So exit. Now we can see in the drawing, this height is also 2 inches. Okay. So we go here and pad this thing by 2 inches. All right, good. Then I'm gonna do this 90-degree surface on the side. See that on the side here? This piece, I'm going to do this piece. So let me go ahead here. And on that horizontal plane, we'll sketch. All right. Of course, I do it very quickly and then we clean it up. So something like this. All right. Dimension. So this is going to be 4 inches. Yep. Actually, that is going to be 6 inches. This is going to be 6. All right. And this is also going to be 6. 6 inches. All right. Now, this is 2. Based on the drawing, it looks like it's 2. Yeah. And so is this one. Okay. Exit. This is a nice closed curve, so I can go to, what is that? To mechanical design, wireframe and surface design. And I FILL it. So fill it. There we are. And then I'm going to draw a line from there to there. So because it's a line in space, I don't need to join anything. So just do a line point to point from here to here. Good. And everything is made out of steel. Therefore, we go all the way to the top and apply material to it. And I believe it says everything's made out of steel, so I'm going to make everything out of steel here. I think it says steel. Yeah, steel. All right. So as far as the model is concerned, this is all done. Okay. Here's my tree, by the way. Yeah. So what I'm going to do is switch to analysis and simulation, generative structural analysis. CATIA immediately sees a three-dimensional object. It meshes it. If you want, you can look at it, but I'll leave it the way it is. I'm going to use linear element, default size. Okay. And then we have to, for example, mesh this surface. And we have to do that ourselves. Here is the surface mesh. Okay, CATIA calls it octave triangle mesh. Yeah, I'll leave it like that. Linear default size. And give it a thickness, 2D property on that surface. The problem statement says the thickness of this thing is, in this drawing, you can see that, 0.1. Yep. 0.1, it is 0.1, very good. And now we're going to mesh the beam. So there is the beam measure right there. Let me move these things out of your way so that you won't get distracted with them. Okay, good. So here's the beam measure. You click on that. Maybe I'll make it 0.1 because remember, one is going to be a couple, at most a couple of elements. I'll use more of them. Maybe 0.2. How about that? 0.2. All right. And then the cross section is circle. So we go to 1D property. You select this. Let me see. It says the cross sections are in this drawing right there. Circular with a radius of 0.05. Okay. So we go here. change this thing to cylindrical beam, which means circular cross section, radius 0.05. 0.05. We say OK. We don't need an orientation point. We can close it. Notice that it did actually draw a circle here. You can see that. Very good. And remember, you have to save the analysis, and later on you submit your analysis and your part file. Here there is a single part, so part file. Okay, so let's go ahead and apply our restraint. First of all, I'm going to hide this sketch. This sketch was sitting here. I hid it so that I can actually apply things to it. So this is this. You see that? Let's do the surface slider first. So surface slider on this side face and the other side face. These are planes of symmetry. Okay. When it comes to edges of the shell, I have to do it with a user-defined restraint. So this edge lies in the, you look at your coordinate system, lies in the YZ plane, no displacement in X, rotations opposite. Okay. The other side meaning that edge lies in the XZ plane and therefore no displacement in Y, rotations opposite. Good. Some stuff are clamped up here, this and that are clamped. You're told is clamped. So clamp this edge and that edge. Very good. And now we're going to apply a force here. Now remember, the total force was 100, and we are taking 1/4 of that. So that's going to be 50 pounds on these two. So I'm going to apply force on this edge and that edge, and a total of minus it was 100 divided by 4 minus 25, right? Minus 25. Yep. 25 pounds. You can see that right there. You can see that. You see? On this edge and on that edge. Now we have to create connections, otherwise it'll fall apart. Okay. So the only connection that we need is between the end of this rod and this corner point. That's going to be rigid. And between the end of that rod, the other side, and let me hide this, and that corner point. So we need two connections. One of them is going to be, okay, let me hide the surface, select that point. And for the second one, I go and select this corner point. Let me bring this thing in the front. And I'm going to hide my beam so that I don't accidentally select it again. Now, this icon, this white dot here, prevents me from selecting that corner. So I'm going to hide that. And now I select this corner point. Vertex. See that? And then we say okay, and this is going to be fastened. All right. So let's see now. Did it create the connection here? Yep. Here's one. And the other one is there. Okay. So another connection between this point. And for the second component, I need to take the end of the line. So let me bring this thing in the front. I'm going to hide this icon. Oops. Control Z. Control Z. Okay. See, the thing is that hiding it from here may be harder than hiding it from the tree. So I'm going to hide that. And the end of this line. If there is any doubt whether you're taking the one from the block or the line, hide that so that you don't make that mistake. There. And then we say okay. So these I hid them because I wanted to pick stuff. It doesn't matter if you can just bring it here. It's just going to be a white dot. Look, just a white dot there and a white dot. I really don't need it, but if you insist, right there. Now these two are going to be rigid, so they're checking connection property. Now in the version of CATIA that you are using, the rigid is right there. Okay, mine, it happens to be the first one, but anyway, you're using this version. Okay, so click on the rigid. This is rigid. You can see that rigid connection. You select this one, and all the degrees of freedom are transferred, because it doesn't say anything whether these are cable or not. And let me see on the statement. It doesn't say anything about these being cables. But if they're cables, remember, you have to release the appropriate degrees of freedom. Yep. Yep. Doesn't say that. Okay. Good. So let's go here. So we say okay. And then do the other one. I did the first one. Let's do the other one. Another rigid. That must be the second one. Yeah. And then say okay. And hopefully we haven't forgotten anything. Let me bring that thing in the show mode. You don't have to. It's going to run without this being in the show mode, but I brought it so you can see what's going on. And let's run it, see what happens. Yeah, that's fine. We know that. Yes. Nothing fancy is going to happen. Basically, this is going to go down. Okay. You can see that. There we are. All right. So animate. That's exactly what we expect to happen. Notice that these things, this thing bends because we're not talking about a cable. This is just a beam. Now, you can also plot the deflection. Obviously, that massive block is going to move very little. That's why it all kind of shows in the same color. Okay, it's just that this is very flimsy. It's going to go down pretty much as a rigid body. When I say flimsy, it's going to go down as a rigid body, and then the beam bends. And you can also plot the von Mises stress if you want, and it's going to be stress in that corner for sure. All right, so that takes care of this problem. Now, what I want to show you is a situation where you may be getting some error messages when you try to join stuff. You get two error messages. Okay, so I'm going to do that in the context of this example. Okay, so first of all, don't worry about whatever is on the left side, this dialog box. The one that you have in the lab is actually the more modern version of the dialog box on the left. So there is an extra thing here that I don't have it. Okay, but however, right now I'm using the version of the CATIA that you have it on your workstation. So what I'm going to do is I'm going to create two surfaces like that, and I try to join it and see that I will be getting an error message. Okay. Now, yeah, and once I join it, then I'll show you an example. Where, for example, one of these I'll take it to be clamped. This is to be clamped, and then I'll apply pressure here. Okay. The reason that I want to do this is show you what is this message that pops up. Okay. So let's go ahead here. Don't worry about any dimensions. I'm going to get rid of this. I'm not worried about any dimensions. So let's get rid of this. Start with the part file. There we are. And I'm going to draw a circle, no, draw a plate here. So I'll measure this with later on with shell elements. So on that, I'm going to draw a rectangle like this. Let me put some dimensions here. So again, dimensions don't matter, but I'll make it 5. And I'll make this one maybe 2. Okay, good. exit, and I'm going to put a surface on that, and surface is just that FILL. Okay, good. Put it there. And then I'm going to draw another one of these a distance away. So why don't I do the following? Why don't I create a plane, maybe 5 inches, 3 inches away from this? So your reference elements, you need you want to make a plane here, right? But unfortunately, I have killed some of these things. So let me see if I can get it. You can reset your toolbars and everything, but otherwise I'm going to say view toolbar. I know what the name of that thing is, reference. Do you see any reference elements here? No, no. Does it go down? Okay, I don't see it there. So that being the case, I am stuck. And what I mean by stuck is that I'm going to, because I can't find it. I think that was the name of it. Okay, so what I did is this. Look, I said tools, customize, toolbars, restore all contents, and restore all positions. Everything is going to go over to they belong, and there we are. This is the thing that I could not find. See that? It's called, oh, it was called wireframe. I see. In part design, this may be called reference elements, but here it's called wireframes. Okay, fine, fine. So click on that, and I want to make a offset from this plane by some distance. So let me move this thing up. Okay, good, good. So on that plane, I will draw another rectangle like that in the same dimensions. And you know how to make it the same dimension. You select this point, control that point, and you say coincident. That will make them the same dimension. Very good. Exit, and put another surface there, FILL. So let me move these things out. There is FILL. You say okay. Good. Now, suppose I want to join these, okay? For many reasons, okay? Because I don't want to mesh them separately, etc., etc. But anyway, when you try to join, let me take the join, which is join, the operations toolbar, which has the join in it. You click on it, and you say, that guy and that guy. Okay, notice that this dialog box that you see here, this dialog box is what I showed you there. And I said that in my older version of CATIA, I don't even have this, but that's okay. But you do it now. And then when you say okay, it's going to come back and say, wait a minute, this message. What this message means is that these two surfaces are not touching each other or connected. So the question is, how do we do this? I mean, look, it says if you want to display diagnosis, click yes, blah, blah, blah. So let's say yes and see what happens. Okay, so we go back to where it is. Now, it is this box that I have to uncheck. See that? Check connectivity. See? Over here, I'm going to click on that. Uncheck this. Okay? Uncheck that. Okay, so let's see what happens when I uncheck it. I go here, and I say, uncheck this. All right? And then I say, okay. And it joined it. Right there. So in that situation, you uncheck this, and it's going to work fine. It joins it. So let's do the rest of the problem. Now that we have made all the effort, let's put some material on it. Apply material, I don't know, make it out of aluminum, and it puts it on both because these are now obviously, it puts it on part because this is a single part. Doesn't matter. But the more important thing is that when you go to analysis and simulation, generative structure analysis, when you say mesh it for me, let me change the rendering here. When you say mesh it for me, it'll do them at the same time because these are joined. Okay? And you can see that if you say, all right, show me the mesh, right click, mesh visualization. There we are. Uncheck that. If you want to put it the same thickness, click on 2D property, select one of these. Because you joined it, it puts us on both of them. Now, by the way, you know that in the event that you want to change the thickness of one of them, you can go right click, local 2D property. I don't want to do that, but anyway, right there. Let's do the rest of the problem. I'm going to hide the sketch because I want to do, put restraints on it, clamp, etc. I'm going to hide that. All right. So let's go ahead and clamp some of these ends. For example, clamp that end and this end. Okay. And we apply pressure. One of them I'm going to put on the top like that. So this is going to push up. All right. And on the other one, I'm going to make sure that it pushes down. So I put a negative. Numbers are not important here. It's just that I want to show you the process. So when we run it, this guy should go up. The other guy should come down. Yeah. This is going down. It's just that this is so flimsy because smaller piece has been clamped. If you look at the deflection numbers, you see that these are very small. Let me change it. Let me change the rendering here. You might say, I don't believe you. I'm going to say, fine. Let me go ahead and, for example, double click on this, make this thing, put more, I don't know, 0.1 MPa, bigger pressure on that, run it. In there. What did I do here? Did I change the sign also? Oh yeah, no, that's pushing down. Good. Run it. Okay, activate it. Yeah, you can see that. Okay. Good, good. So that takes care of the whole purpose of this exercise, was to show you what happens if you get this kind of a message. You have this dialog box. In older versions, going back to release 21 and things like that, 20 and 21, this dialog box is not exactly the same thing. Okay, so there's some stuff missing there. All right, good, good. Now, what I want to do is, in the case that you're doing some beam problem, you may be coming across another message which says non-connex result. We already saw that, and a non-manifold thingy. Okay, so what I'm going to do is I will try to do that problem for you. In other words, three beams, clamp, 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 and then a force here. Okay, we know how to do it. Okay, so let's go ahead and do that. I want to reproduce that error message for you. So let's go ahead and go here. We don't need this. We don't need that. All right, start with the part file. I'm going to create some, I don't know, some lines. All right, some lines here. Well, first of all, if you do lines in space, let's do let's do lines in space. So let me first try to do it for you in space. Okay, so let me create 4 points. This is 0, 0, 0. Another one. Okay, I'll make this thing x of 6. Good. Another one. Maybe y of also 6 and 2. Oops. And y of 6. Okay. X of 6. Good. Good. And another one. This time z of about 6. Fine. Now I'm going to create a line between this point and that point. Another one between this point and this point. Cancel that. Try it again. Between this point and this point. And another one between this point and this point. Okay. Good. And now we're going to join it. Join these 3 lines. So click on that. 1, 2, 3, and okay. So you do get that message. All right, you do get that message. So how do we do that? Well, first of all, if you say yes, all right, if you say yes and uncheck, you see this box, check manifold, uncheck it. See, I'm showing you this thing, okay? I'm unchecking that check manifold. And then say, okay, it goes away. By the way, when you look at the joint, notice that when I uncheck this, this thing also went with it. Good. We say fine. Now let's do the rest of the problem. Apply material to it. Aluminum. Good. We go to the analysis and simulation, generative structure analysis. We mesh these 3. Because we joined it, it will mesh all 3 of them at the same time. What happened to the other line? Did I miss it? Oh, oh yeah, there it is. There was a illusion here. So we're going to mesh this. Because we joined it, they're going to mesh them at the same time. There won't be any duplicate nodes there. Yeah, that's fine. I'll leave it like this. Give it a 1D property. Everything, we're going to make it a circle of that same radius that I had before. All right. Let me try it again. Join. You say okay. Good. And now we're going to clamp these. Do not forget to hide these points, because if you put a clamp on a point, you're going to have a problem. So let's clamp them. 1, 2, 3. Okay. And I'm going to apply a force to that common location, hide the point. So apply a force in some direction, maybe, okay, right there, in this direction. And then we say, okay, and we're going to run it, and there won't be a problem. Okay, here's a reflection. You can see right there, and you can animate it. Remember, the key was because these are coming together like that, essentially you get this message. Okay. Now, if I had only 2 of these, there won't be a problem. But you can think about this thing as basically I have 2 lines, and then I stick this line to that line. See these 2 lines? These 2 lines essentially become 1 line when you try to join. And then you're trying to stick this thing in the middle of another line. That's why it doesn't like it. So I'm going to repeat the same problem, except that I'll do it as a sketch. Right now, I did it as a three lines in space, but I'm going to do that as a sketch. Let's see what happens. Basically, this is what happened. This is what I just showed you, okay? So I'm going to do that as a sketch, and here is what I'm planning to do, something like this. For example, let me close that. I don't need this. I don't need this. So I'm going to start with the part. Okay. For example, on that horizontal plane, I will sketch 3 lines. Here's one line. Here's another line. And here's a third line. Exit. Okay. Let's try to sketch it, fill it, join it now. Click on that, and I say OK. Same thing pops up. We say OK. Yes. Uncheck the manifold, and then click on that. Notice that it joined it. Okay. Let's put some material on it. On the joint, aluminum. Okay, good. And now we're going to go to analysis and simulation, generative structure analysis, static analysis. Let's mesh. This is all joined, so it's going to do it at the same time. Let's put a 1D property on it. It's all joined. It's going to put same at the same time with that radius that I gave it. I don't need an orientation point. And we're going to clamp this and that and that, and apply a force to that location. Remember, I don't have points here because I did it with a sketch. You see that? And then we run it. And it's going to work. Look at the deflection. There we are. So the moral of the story is when you get messages like this for surfaces or for beams, you have to worry about these two checkboxes, okay? And hopefully if you uncheck it, then it's going to work, and it will, unless there's something else that's wrong. So that takes care of this tutorial for today. And remember, on Thursday, I will do a review in the sense that we'll do some problems, and hopefully it's okay. It's okay with you. You can do it too.